So how is it valuable to have these groundwater models be incorporating new data all the time? Well, we'll go through two examples. So in this case, we've built a model in the yellow there, and then say there was either a new sensor went in just outside the area, or consultants went and collected more data. And you realize, oh, that's actually outside of where we think our plume is. So let's incorporate these new data into our model. And now it looks something like this. So whereas you can see on the south end here, oh, we're very confident, based on the data, there's not a lot of spatial variability in the plume extents here. Whereas where we got those new data, okay, well, if it's this concentration here, we know it doesn't just go to zero right adjacent to that. So we're a little more uncertain here. So maybe if we're gonna focus our sampling efforts on just a portion of the site, this might be the prime suspect here. And then this is an iterative process. If it's whether it's field data or if it's autonomous sensors, which would give you quicker updates, you're constantly updating this model. And because I'm a little simpler, I like analogies. So this is a more general explanation of the process. That you have your initial model, you simulate new sensor data, then you get an updated model that hopefully gives you more confidence because you've got reduced uncertainty. And we talk about groundwater, so this could be plume stability, but if natural depletion is the question, or is a remediation treatment effective, that's how we can gear the model outputs. And this is iterative, so it keeps getting updated. Hopefully you're getting this reduced uncertainty. And the reason why we have this picture up here is it just reminded me of how I went bowling last week. This is me. They have these bumpers up for people like me that, what if something goes wrong at the start, or there's something might not be up to snuff. So for instance, with data collection, maybe one of the samples isn't robust, or, it was a super rainy day, it was rushed. So you just have this one data collection and your model is based off of that. You just let it go. If you have poor data going into the start, you might not get that strike at the end. It might not be representative of what site conditions actually are. But if you're constantly nudging that model, kind of like how these bumpers are constantly nudging the ball down, then you're reducing your uncertainty and you're putting a lot more data in. So you get a lot more confidence that, okay, what's coming out the other end is something that is probably more representative of what's going on at the site.